This lesson is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.6, graphs of transformed sine and cosine functions. So if you want to go ahead and open up to page 5.1 in your calculator, we can get started. Okay, so what we're going to talk about today is combined transformations. Things get a little tricky when we start combining different types of transformations with the amplitude and the midline and phase shift. So what we're going to do is we're going to look at the file on, or the page on the next screen, and we're going to play with these parameters and see what happens when we kind of combine these transformations. Okay, so what I'd like you to do is I'd like you to pick one transformation at a time and adjust it. So what I think what we would like to do is start with D. We know that D represents our midline, or we call that our vertical shift. It raises our function up and down our y-axis. So we always start with that midline. Okay. The next place we want to go is to my amplitude. Okay, that's A. So that vertically stretches my function. The next thing we can do is change our frequency. Frequency is how many full curves we see within 0 to 2 pi. Okay. And then lastly is our phase shift, which moves it left or right depending on the value of C. Okay, so you could spend a little time playing and figuring out how this works all together. Alright, so what we're going to do is we're going to sketch the graph of y equals 3 sine 2x plus pi over 2 plus 1. So go ahead and get your piece of graph paper out, and we'll work on sketching this. Okay, so the first thing I'm going to do is kind of pull apart what I have here. I know that my midline, and I'm going to shortcut here, is going to be 1. My amplitude is 3. My frequency in front of the x is 2. My phase shift I have to work for. Okay, remember when I said when we were finding phase shift, if the frequency was something other than 1, we needed to divide everything by that frequency. So I have to kind of like factor that out. So this is going to become pi over 4. Okay. So this is going to be pi over 4 to the left. Okay, so negative pi over 4. We want it to the left. Okay. All right, my period, since I have this, my period is 2 pi over b, so 2 pi over 2, which is pi. So that means I'm going to have one full curve between 0 and pi. All right, so let's put together our starting point. So I want to put my midline on there so I have it there to kind of work around. So I'm going to sketch that in, just to give me a vantage point, because that's like my new x-axis. Pi over 4 to the left is going to be like my new y-axis. So I'm just going to real quick kind of put that in as well. And I'm moving to the left, so I'm going to shift it to the left of the origin. All right, so I know sine starts at 0. Okay, so this is going to work the same way. So our new x-axis, our new y-axis, we're going to start right here. All right. So sine starts at 0, sine ends at 0, and since I know my period is pi, it's going to take pi to get one full curve. So let's start by evaluating some values here. Let's find at 0 what this function is equal to. So 3 sine of 2 times 0 plus pi over 2 plus 1. 3 times sine is 0, right? 0 plus pi over 2 is pi over 2. Sine of pi over 2 is 1 plus 1. So this at 0, we're going to get a value of 4. Okay, so I know that that is my maximum. Okay, so I'm going from my 0 to 4. So what's going to happen is at pi over 4, I'm going to go back down to my 0. At pi over 2, I'm going to hit my minimum. Now, remember, maximum and minimum I can gain by doing midline plus amplitude, midline minus amplitude. Okay, so 1 plus 3, which gave me my maximum, my value of 4. 1 minus 3, which is negative 2, gives me my minimum. So that's going to minimum out at pi over 2, and then it's going to come back to 0. Okay, so I get one full curve here. Now, some of you may be wondering why it didn't end at pi. Remember, what we did is we shifted it to the left, pi over 4. Okay, so that's why it doesn't look like it's ending at pi, but it did take pi units to get one full curve. We're going to follow that same trend now. This is going to spike up, come back down to 0, bottom out, back to 0, and then spike back up. Okay. We can follow that trend on the backside, and I am splitting these into quarters because it was a quarter shift. So this spikes back down, 0, up, 0, down, 0, up. Oops, up. I have to count. There's no way I can undo that. Okay. I'm yelling at myself here because this piece right here, this should not exist. So I should have stopped on that interval. I apologize. Okay. And if I try and erase it, it's going to erase my entire line. So there's your function. All right, so they are tricky. Again, you put in that midline, you put in your adjusted y-axis, and you start plotting those points from there. If you need to evaluate, you evaluate. Okay? All right, so we're going to graph y equals 2 pi x minus 1. And I apologize. I should have a 3 in here. I apologize for that. Okay? Really, I should have parentheses here. Okay. So go ahead and get a piece of graph paper out and get ready. Okay, so some things we need to go through here. We need to determine our midline, which we know is -1. Okay, our amplitude, which is 3. Our frequency is 2 pi. Okay, it's everything in front of the x, which means our period would be 2 pi over b, or 2 pi over 2 pi, which is 1. So it's going to take one full unit to get a full curve. All right, so there's no phase shift here, which is nice. So let's go ahead and get started. I'm actually going to have you guys put this right into your calculator, just so you see how it's done in the calculator. This will make it a little bit easier. So go ahead. You're going to insert a graph page. And we're going to put in 3 cosine of 2 pi x minus 1. Okay? And we would like it on a pretty interval, so we're going to go Menu, Window, Zoom Trig, and we get a pretty funky graph. Okay? And this is what this function actually looks like. So they can get pretty complex. the frequency was too high, so we really get quite a few curves in here. Okay. Next thing we're going to talk about is graphs of sums or addition of ordinates. So we're going to graph y equals sine x plus sine 2x. So go ahead and get your graph paper and we'll get started. Okay, so the way this actually works is we're going to graph each one of these individually, 2 sine x and sine 2x. 2 sine x is pretty simple. It's a basic sine curve, but it has an amplitude of 2 instead of 1. So like always, we start at 0. At pi over 2, we're going to have 2. Pi, 0. 3 pi over 2, negative 2, and then 2 pi back to 0. So it's our basic sine curve that's simply been vertically stretched by a factor of 2. Follow that trend back, and we get the rest of our curve. Now, my other graph, sine 2x, is a normal sine curve, but it has a frequency of 2, which means we're going to have 2 full curves between 0 and 2 pi. So we're going to fit 1 full sine curve in between 0 and 1 pi. So we still start at 0, but we're going to have to break this into quarters. Okay, so at pi over 4, we're at 1, then 0, then, whoops, negative 1, then 0. So we get 1 full curve here. Okay, follow that trend as we go across. Here's your second full curve. Again, follow that trend back. And here's our other curve. Okay, so this is your sine 2x. This is your 2 sine x. Now, to graph the addition, what we actually do is we take the y coordinates of some given points and we add them together. Okay, so let's find some points here. All right, so we can start by noticing that if it's on the x-axis, those values are still going to sit at 0 because their sum is. So I'm going to go ahead and put those zeros in now with red. So where they're both 0 is where I'm going to put those in. Okay. So now what I need to do is find the sum of these. So you've got this plus this. So if I were to add those together, these two y values, 1 and about 1.5, I would get about 1.5. Okay, I'm sorry, 1 and 1.5 is going to give me 2.5. So this height is going to come up to here. Okay, so it's a guesstimation in this case, okay? 0 and 2 is still going to give me 2. Negative 1 and about 1. Negative 1 plus 1 is going to give me, this is a little over 1, so maybe just a little bit above. Okay. We have negative 2 and 0, so that's going to give me that negative 2. Let's work my way back this way. I've got negative 1 and a little bit less. So when I add those together, let's say negative 1 and negative 1.2, it's going to be a little less than 2. It's going to come down. 0 and negative 2 is going to be negative 2. 1, so this is a height of 1, and let's say this is negative 1.5. 1 and negative 1.5 is going to give me about a negative half. Okay. There was a way to undo. We've got negative 1 and about 1.5, which is going to give us about a half. Okay, 0 and 2 is going to give us 2. And 1.5 and 1 is going to give us about 2.5. And then back down to 0. So our addition winds up looking something like this. Okay, so this red function that's kind of crazy looking, right? Let me do this as a highlighter in red. So it's kind of crazy looking, but this is what that addition winds up looking like. Okay, when I add those together. Okay, so they do look crazy looking, and that's okay. They're supposed to look somewhat crazy. All right, so if you were to graph this on your calculator, you're going to get that same general look. And again, all you're doing is you're adding the y coordinates, okay? So you've got 2 sine x plus sine 2x. So you're going to get that crazy look, all right, which looks very similar to what we graphed. So you do get crazy looking stuff, okay? All right, the next one I want you to graph is cosine x minus sine 3x, and we're going to do this one right on our calculator. Okay. So 2 cosine x, oops, excuse me, minus sine 3x. And here's our crazy looking. So again, this is just by adding those y coordinates. Okay. The next thing we need to talk about is damped oscillation, multiplication of ordinates. So what we're going to do is we're going to sketch this graph. We've got e to the negative x over 2 sine x. And basically what damped oscillation means is, suppose you have a weight that's attached to a spring, and the spring is stretched and it's put into motion. The weight oscillates that spring up and down. If we could assume falsely that the weight will bob up and down forever, then its height h after time t in seconds would give us an equation. All right. Over a short period of time, this might be valid, but experience tells us that eventually that spring is going to stop. So a more appropriate solution would be one that is represented by damped oscillation. So essentially, it's showing a slowing of that spring, or that bounce getting smaller and smaller. Okay. So in order to find damped oscillation, what we do is we multiply the ordinates, or a word for ordinates is points, the y value. Okay, so you find those y values of the points and you multiply them together and you graph that. For the sake of time, I am going to have us do it in the calculator, and we'll look more at it later in class. Okay, so we have e raised to the negative x divided by 2 times sine of x. Okay, so this is what that damped oscillation actually looks like, and the window really is inappropriate for what we want, so I'm going to go ahead and change that to 60. Okay, I'm going to make this a 3. I'm going to make the bottom a negative 60, my y minimum, and let's make this, that's fine. Okay, so that spring drops down and it comes back up, and then it starts to get smaller. Okay, that bounce starts to get smaller after time, and eventually it does come to a stop. So that's an example of damped oscillation. Okay, all right, so that's it for today, guys. Come in prepared with any questions that you might have, and I will see you tomorrow. Bye.